Hey guys, I will be explaining Codeforces round 805 div 3 from A to F. So in the competition I only solved A to E, but I have upsolved F as well. Okay, so let's start. So here are my submissions, by the way. So for letter A, we just have to find, basically we just have to find the largest power of 10 that is less than m, and then we take m minus that largest power of 10. So there are multiple ways to implement this, but I just chose the most intuitive one. So you can also count the digits, but you can just take log 10 of m and take the integer value of that, and then just take m minus 10 raised to k. And you can create your own function uh, because the numbers is just as large as 10 to the 9th. So that means that at most this would be 9 iterations. So it's basically constant time every test case. So yeah, okay. So that's the first problem. Now let's go to letter B. So letter B, just to summarize, basically he can write a string from left to right, but he can only remember 3 letters per day. So the idea here is that we iterate from left to right of the string, and once the number of distinct letters uh, is greater than 3, which is 4, then we will reset and like forget everything, and then we just have to write them down, so increment the answer. By the way, the required output is the minimum number of days, so we just increment our answer by 1 every time it gets to 4 distinct letters. So my submission is just here. So basically I created a dictionary called map. You can also use a set. And then I initialized a variable called count and answer. So for each character in S, if it is not yet seen, then we will increment our count. Now if the count becomes 4, then that means we have to increment our answer. We have to reset our count to 1. We have to reset our count to 1, not 0, um, because we already have a count of 4, but we just have to forget 3 letters, right? So count becomes 1, and then we will reset our dictionary, and then set scene C to be true every time. Now if there remains some more letters, right, because we're taking the ceiling, so say we have 2 more letters left, or 1 more letter left, or 3 more letter, or whatever, then we will just increment our answer, then we'll print our answer. Okay, so next problem is letter C. Okay, so basically to summarize, you have stations and you can only travel from left to right. So you're given A and B, and A is any station. There can be multiple or duplicate stations, right? So you will see if there is a way to go from A to B. And the constraint is that you can only go from A to B if A is to the left of B. And obviously if A and B exists. So how do we implement this? Well, we take the most greedy solution, and we will take the first position where each number appears, and the last position where each number appears, because there can be duplicates. So, okay, so how to do that? We can create a map, and then map first and last, and then we will just set the positions. So the importance of making it one indexed is so that if it doesn't exist, the value would be 0. But the first instance can be 0, right? Like if it's 0 index, it can be 0. So there will be some problems with that. So I made it one index to make things life easier. So for each k queries, just take in A and B, and if the position of A and position of B is exists, so if A and B exist, right, we will check if the instance of A is less than or equal to B. So equal because A and B can be equal, right? Like they can be the same thing. So you can just travel from the same station to itself, right? So print out yes, otherwise print out no. Okay, so let's go for letter D. So for letter D, basically to summarize, you have the price of a string, and it is just the sum of the indices of the letter. So A corresponds to 1, B corresponds to 2, C corresponds to 3, D corresponds to 4, and so on and so forth. So just take the sum. And then we will just remove letters until it becomes less than or equal to P. And your goal is to remove as few letters as possible. So how do we do that? Well, this is another greedy problem. So you want to remove the highest indexed letters as much as possible, and this will be always the optimal solution. There are other possible solutions based on the string, but it does not guarantee that it's the best for every case. But this greedy solution will be the best. So okay, so how do we implement this? So how I implemented this is first take in the sum of the indices for each character. So one way to do that is take C minus A plus 1. Okay. And then take a copy of the of S, and then we want to sort it in descending order so that we can take every highest indexed letter. And then what I did, which is better to do, is to determine the frequency of the letters that we must remove, right? So for instance, let's say the sorted string is like C C C C B B A, and what we want to remove is C C C C C C C B B A, right? So that will be like, say, 7 for A, and then 2 for B, and then 1 for C. So how do we determine how many letters and what letters should we remove? Well, we take a loop until the sum becomes less than or equal to P. So while sum is greater than P, we subtract the index of each letter in the sorted string from left to right, and then we increment its frequency. Now what we will do is, for each character, if we don't have to remove the character, then we just add that to our answer string. Otherwise, we will just decrease the frequency of the letter, okay, that we must remove, and finally print out the answer. Okay, so let's go on with the fifth problem. So for the fifth problem, hopefully it just loads. Okay, so the fifth problem, basically you have dominoes, and each domino has 2 numbers, and your goal is to split the dominoes, the set of dominoes, into 2 sets such that no number exists in the same set. So there's no duplicates. So for instance, 1 4 3 2 and 1 3 4 2. So if 4, 2, and 1, 4 exist at the same time, then that's impossible. Okay, so how do we solve this? Well, we think of this as a graph, and since these two are like in the same pair, that means they're kind of connected, right? They're connected in that graph. So think of these as 1 to n vertices. Now, in order for them to be split into two sets, what you can do is check if the graph is a bipartite graph. And the only condition that you have to check there is if there does not exist any odd length cycle. So if there is an odd length cycle, you can try, right? Like, um, you cannot really place, for instance, like 1, 4, 2, 4, and then 1, 2. That's an odd length cycle. It's cycle length 3. And you can not really put 2, 4 at any position, because if 1, 4, and 1, 2 exist at the different sets, you cannot really put it anywhere. But if it's an even length cycle, say 1, 4, 2, 4, or 1, 4, 4, 2, 2, 3, 3, 4, 3, 1, or something like that, then we can just split them into two, right? You can always find a split into two. And the first condition that you want to check first, obviously, is if the frequency of each number is less than 3. Because if it is 3, then, or less than 3, or, yeah, because if it is greater than 2 or greater than equal to 3, then that means that you cannot really have split into two, right? If you have 3 ones at any point, then it's just impossible. Okay, it also covers the case when A is equal to B, so say 1, 1, because that's technically an odd length cycle. Okay, so to implement that, you can use any standard code to check if the the graph is a bipartite, and to optimize your solution, you want to store it in an adjacency list. This is O of n. If you store it in an adjacency matrix, it will be n squared in the worst case, so it's kind of hard. Actually, not the worst case itself. I don't know. I think, yeah, worst case. And then just take in the input A and B. Actually, first check if they only appear less than 3 times. So one way to check it is if it is greater than 2, then we just break it. Okay, so you can store it in a map, frequency of each number. Now, if we pass through this procedure, then we can start building our graph and checking if it is bipartite. If it's a bipartite graph, then we print out yes, otherwise we print out no. Okay, so we can also explain this code here. So how do we check if a graph is bipartite? You can do multiple ways, but one way is to color the graph. So how do we color the graph? So we basically mark them, and such that any two adjacent vertices must be colored differently. Okay, so if you have a vertex and you have its adjacency list, then all of that vertex in its particular list must be colored differently than the current vertex. So one way to do that is to use BFS. You can also use DFS, it doesn't matter. So you create a queue, and then you iterate for each vertex. So if the vertex is not yet colored, which means the color is still -1, then we will push that vertex in our queue, and then we will color it 0. You can also color it 1, it depends on you. And then while the queue is not empty, which is our main BFS, we will take in from the queue, and then we will take the V as the first pair, basically the vertex, and the P second, which is our color. So for each of these, for each of the adjacent vertex to the current vertex, we will check if first the color of that adjacent vertex is the same as the current vertex, then we will return false, right? If they're colored the same, okay, we don't do that. But if it's not yet colored, then we will color it differently as the color of the current vertex. And then we will push in the new vertex. And we just keep on doing this, and doing this, and this is, I think, an O of V plus E. I'm not entirely sure. But yeah, that's the time complexity of this bipartite function. So that's basically it. And now the last problem that I could solve right now is multisets. Okay, equate multisets. So this problem, basically, just to summarize, this is similar to ABC 254EX. So what you want to do is, okay, so just to summarize, you have two multisets, A and B. And in B, you can do it. What you can do is you can multiply a number by 2, or divide it by 2 and then round down. So take x floor 2. And then here's an example. So you're asked to find if you can turn B to A. So one observation that you can make is that you can always divide everything by 2, right? Like everything in A by 2, because you can just multiply by 2 in B, right? If that makes sense. So what we can do is just divide every single element in A by 2 until it reaches a point where you cannot divide it by 2, meaning 2 does not divide a number. So for instance, 4 we can just make it 1, 24 we can make it 3, and 2 we can make it 1. Okay, that's the first instance. Now the next thing is that we don't really want to multiply by 2 in B, technically, right? Because you cannot make A larger, right? So you can only make B smaller until it reaches a point where it's equal to A, right? If that makes sense. So you can really just divide by 2 in B, right? So that's what you want to do. Now, you want to order this multiset B, okay? You want to order it, and then you want the highest number in that one. You want to keep dividing it by 2 until it becomes one of the elements in A. It does not make sense to take in, like, uh, it does not make sense to not remove it already from A, because if there exists another one, then it's just another copy, right? It doesn't matter, right? So you can, once you find an equal to A, then just remove that, right? And we always start from the largest. Now, if we don't see it to be in there, in A, then that means we have to divide that largest number in B by 2. Now, if the largest number is 1, then that means you cannot really, and then you cannot find it in A, then that means that it's impossible, right? You cannot make it smaller, right? Because it's already 1. So it will just turn into 0. But in A, it's greater than or equal to 1. Okay, so how do we implement this? You can make use of the multi-set data structure. A multi-set data structure basically sorts the array already. Like every time we insert a number, since we're not really accessing it with the index, whenever we insert it, it's O of log n. So basically it uses binary search whenever we insert a number. So that's what we want to do. First, we want to divide, like keep on dividing each AI by 2 until it reaches a point where you cannot divide it yet. And once it reaches that point, then we insert it in in the first set, and then we insert the second BI's to the second set. Now the next thing that you want to do is create a while loop. So while S1 is not yet empty and S2 is not yet empty, we keep taking the largest number in the set 2, or the set of B. This is how you want to do it. It's R begin. So it's like reverse begin. Now if how you want to do it is if we cannot find L in the first set, which is this implementation, then we will check. Okay, so if L is equal to 1, then that means you cannot really divide it by 2 anymore. So just break the loop and print out no. Otherwise, if it's not 1, if it's greater than 1, then that means that we can just erase it from the second set and insert it L over 2. So basically we're replacing L by L over 2. Otherwise, if we can find it in A, then we just remove it. We just remove both of them. Okay. Now the next thing that the final thing they want to do is, if it is okay and both sets are empty, right? You can also say just S1 to be empty, I think, or S2 to be empty. Then we print out yes, otherwise we print out no. So that's basically div 3 Codeforces round 805. I can try out G in the future. The only reason why I haven't tried it yet is because I haven't tried it yet in the actual competition. I tried F in the actual competition, but I just didn't have enough time to finish it up. But yeah, that's pretty much it, and I hope you guys enjoyed and learned something from this video.